Okay, here's a question from the chapter 8.1 homework, and I think it's this number 9. The student had a question about B and C. Suppose Jack and Diane are each attempting to use a simulation to describe the sampling distribution from a population that is skewed right with a mean of 70 and a standard deviation of 5. So it's not a normal underlying distribution. But we know that Diane obtains 1,000 random samples of size 3, right? Each sample has 3 people in it from the population, or 3 things in it. Whereas Jack does the same simulation of 1,000 samples, but with 30 in each of the samples. So the first part the student got right, describe the shape you'd expect Diane's distribution. Diane's is expected to be skewed right, but not as much as the original distribution, right? It's kind of normalizing it, but with a sample size of 3, that's really low. So it's not enough to get it to be approximately normal, whereas Jack's 30 gets it above that bar, and we can see that Jack's distribution of the sample mean is approximately normal. And then ask, what do you expect the mean of Diane's distribution to be, and what do you expect the mean of Jack's distribution to be? Well, really doesn't really matter how you sample, or how many things are in your sample. The sample the mean of the sample distribution is supposed to be the same as the underlying, so we can write, I think it's 70, and the mean is 70. So both Diane's and Jack's sampling technique should give us a sample distribution with the same mean. Okay. What changes, of course, is the standard deviation. The more that you sample, the larger your samples are, right? I shouldn't say the more you sample, the larger your samples are, the tighter that standard deviation gets, the smaller it gets around the mean. And we've got that formula for it. We just take the original distribution's standard deviation, and we divide it by the square root of the sample size. So for Diane, that's 3. Take 5 and divide it by the square root of 3. And that gets us a standard deviation of about 2.89 if we round to 2 decimal places. And then all we have to do is change the 3 to a 30, right? Because Jack does he samples with a population size or sample size of 30. And as expected, right, this is a lot more, the standard deviation smaller than Diane's. And it's at 0.91. Okay. So I hope that helped on that question. Right. The sample size affects the standard deviations, but not the means of the sample distribution.